Hello, my name is Alistair. As many of you know, I've been building a single-seater Austin 7 based race car for hill climbs for the last 4 years, and the last 10 months I've been having problems with the brakes, the hydraulic brake conversion, and I thought I really ought to share this information with the Austin 7 community, so I've put this video together that I hope will help with people with similar conversions and the problems that can arise. I'm going to try and cover most of what you're interested in. Basically, I've taken the view that imagine that you're on the process of starting to convert your brakes to hydraulics and what problems you'll encounter, and roughly speaking what order. First order of business is the backplates. First you have to choose whether you're going to modify Morris Minor backplates in steel. There's lots of videos on YouTube about that. I chose to use aluminium backplates. I purchased them from Ulster 7s in Ireland. They're reasonably readily available, but you won't get them machined. You have to machine themselves, and this topic is more than adequately covered in another video of mine on this channel, so I suggest that you hunt that out if you're going to machine the aluminium backplates, because they don't come machined. The next topic we need to cover is the gap required between the Morris Minor hydraulic cylinders and the axle flanges, the ones that hold the wheel on. There is insufficient room there, and you need to do a bit of bodging here, to be want of a better word, with a flat wheel and an angle grinder to create some space between the wheel cylinder and the studs, which are the first thing that the studs that hold the wheel on, the first thing to contact the wheel cylinders. In my opinion, this is the crux of the Austin 7 hydraulic brake conversions. Okay, you've got cylinders, okay, you've got a system that works, but the fundamental issue is the brake lining material and the contact with the drum. You've got to sort of maximise that. Now this item has been rigorously researched by Paul Neil McLaughlin of Vintage and Classic Workshops, and he has actually written a paper which is in the background of this video. You'll find it on Friends of Austin 7, and if you look for brake, comma, brake, comma, brake, you'll find an extensive analysis of the work done by Paul to obtain the correct lining material and the manufacture of that lining material by a reputable company. It's not cheap, but there is no way around it. There's no point in doing, in my opinion, the hydraulic conversion unless you go down this road. I've just put up a slide that gives you the information required to find the company that we use to make the brake shoes for this project. You may have difficulty. If so, you have to get in touch with me via personal message, and I'll help sort it out. The next topic I want to cover is the retaining mechanism, which is normally a spring, a beehive spring, and it's held through the shoe, through the back plate, and sometimes there's a split pin and you bend it over, and it's got a fundamental problem. The tolerances of the back plate are such that if you pin that shoe to the back plate, it will cant, and when it cants, it does not line up when it's actuated with the brake drum, so it goes through a period of righting itself before you get any effective braking. This gives you a long pedal, it gives you ineffective braking, and it's basically a disaster when you use an aluminium backplate. If you use a steel backplate, you probably won't get this problem, but aluminium backplate you will. So basically this design is made out of Teflon. Teflon was a space age material. It's commonly available now. You can buy it as 15mm bar. You cut part it off, well, you drill a hole through the middle 6mm, you part it off at 16mm, and you countersink the spacer at 10mm for diameter 10mm for a distance of 10mm, and the diagram shows you the rest. Note the position of the various parts. You can see the adverse wear pattern on this brake shoe due to the fact that the beehive spring is actually pulling the shoe towards the casting, and the casting is not properly spaced away from the brake shoe to make it line up perfectly with the brake drum. The next item on my list is the return springs. The Austin 7 conversion, as far as I can understand, only uses one of the types of springs fitted to the Morris Minor. That's the one with the 2 bits of spring at either end and a link in between. Now, unfortunately, it would appear that there was an issue with the Morris Minor at some point with the back brakes binding, and they increased the tension in that spring. But it would appear that this hasn't been picked up by the Austin 7 suppliers, so you may find that the springs are not the correct tension. There's an if you do a search with Google like I did, you'll find that this is all highlighted, and there's a specific set of part numbers that will give you the correct tension. There's also a set of tests you can do. And that test is, in my case, I took a 3.75 kilogram weight that I found lying about in the workshop. It was nothing special, and I tied it onto the ends of the spring and measured the elongation of the springs. And what I found was that the ones that were not correct had about a 50% increase in elongation relative to the correct ones. And so you can, the only way you can really tell is by doing this, because the actual colour of the spring, it can look completely different and yet perform exactly the same. I've got set up here on the bench a Woolwood pattern type master cylinder. This is not a Woolwood part, but they all do the same thing. This is a 0.5 inch. I don't think Woolwood make a 0.5 inch, but you can see that sitting on the in the vise here, if I press my compressed air, there's a return path for the brake fluid to go through the cylinder. If, however, I move this only very slightly, only a millimeter, and there's no path through that cylinder. So that means that only when your brake pedal is released do you get this back pressure allowed to release into your reservoir again. This is the actual thing that does it. This is a identical one to that. But if the shape of that at the end of there is wrong, which it was in my case, I doubt it was a Woolwood part, but it was supplied with me with all the parts that I required for my balance bar arrangement, and when it was put in here it didn't work, and I didn't know that it didn't work. That was the problem. It took me 10 months to find out. The illustration next to me is my recollection of what I did to the push rods, the extended push rods, which were the wrong shape. Please don't take them literally, but it gives you a rough idea. It must have been an aftermarket push rod for the master cylinder, and it did not fit in the master cylinder such that it gave you a return path. But it's just an illustration of the type of problem that you get. This part of the presentation is about the pressure retaining valves. I fitted 2 of these, one in the back brakes and one in the front brakes. Why do you need these? You need these to give you a good pedal. Basically, it preloads the system with £10, and it's got a little regulator built into it, so it will not give you any more than £10. It's just a little bit of pressure to help produce a short pedal rather than a long pedal. This is getting near the end of the video now, and the last subject I'd like to cover is the brake drums. The brake drums have to be cast iron. Pressed steel ones will not do. The brake lining material is tuned to cast iron type of drum, and to get a pedal, the correct pedal with hydraulic brakes, you need to get access to the adjusters when the brake drum is screwed on tight. If you don't do that, you'll end up with a long pedal and you'll be coming into the corner and braking, and your pedal will be at the floor. So adjusting the brakes is absolutely essential. Once your brakes have been adjusted and set up according to Alistair's rules, there's one thing you should test for. On a level surface, you should be able to move the whole car with one finger back and forward, and that's with all of the snails aggressively adjusted so that there is no spare clicks anywhere on all four corners. This doesn't result in any drag, and it gives you a good pedal. In other words, only about an inch or two before you get full grip.